Hi everyone. Today we are going to talk about how to do subsetting or analysis of subpopulation using the complex survey data. So just to motivate the problem, let us use a data that I have downloaded from Enhance 2017-18, and just to simplify the problem, I am again going to predict the binary categorization of cholesterol, whether the person has a healthy cholesterol level versus an unhealthy cholesterol level. And we are going to categorize based on a specific cut point. And we are also going to use a number of variables that we already have in our data. Some of these variables are survey feature variables, and some of these variables are basically predictors of cholesterol, and cholesterol itself is the outcome variable here, and diabetes is another predictor of cholesterol. All right, so in this data, we basically try to check whether we have any missing observation, and based on this plot missing from the data explorer package, we can see that in the whether born in USA, whether they have diabetes or not, the BMI level, as well as the binary cholesterol variable has some missing observations. All right, so in this analysis, say for example, one of the eligibility criteria that we are considering is that we are only going to restrict our analysis for those for which we have complete observation, right? Obviously, next, when we learn about the missing data analysis, we will learn about more appropriate approaches to deal with missing data, but we are just using this scenario to motivate how we can do survey data analysis in a subpopulation. All right, to subset the data, before talking about any of the complex features, let us talk about how can we subset the data. So we have a full data that has about more than 9,000 observations, and then we can check the IDs of people who are in the full data source. So we have like this 03, 04, 05, 06, 07, 08. All of these people are in the full data set. All right. Then we can try to subset the data based on the NO-MIT function to check who among them have the complete cases. So all of the variables have some information. So there are no missing information. And based on making this complete case data, we can see we only ended up with more than 6,000 observations. So we started with 9,000 and then we ended up with 6,000 observations, right? And then we can check who are in the complete case analysis. So 05, 06, 07, 08, 09, 0, and 11 are in the complete case, whereas in the full data we had 03, 04, which are not part of this complete case anymore, right? And then we can also try to see when we use this in function, percent is a function in R that helps us identify who are the people who are in the complete case, who belongs in the complete case. So within the full data set, who are the people who belongs in the complete case? That's what this is basically doing. And you can see this after using this in function within this full data, we can see 0506, which completely matches with the information that we got from our complete case only data. All right. And if you want to learn more about why we need these full data and this complete data, you have to understand that when we are subsetting based on who have the full information or not, and that is our criteria, we need to make an indicator variable say for example, in our case, we name our indicator variable miss, and we assign everybody miss equal to 1. And then we try to check who among these people who are in the full data are also in the complete case data, and those who are in the complete case data, we assign 0. That means whoever has miss equal to 0, they do not have any missing information, or their information is complete, and rest of them will have some missing information. So in here we can see, based on this, that more than 6,000 people do not have any missing information, and more than 2,000 people have missing information in at least one variable, and this 6,636 matches with the complete case data that we have created previously. All right, and then we can try to see whether it matches with the IDs that we had previously. So these 3, 4 are the observations that were associated with missing, and that is what we are seeing in these cases, that 3, 4 were in the full data set, but these 3, 4 were not in the complete case data set, right? So this is basically a check whether we are getting the exactly same information that we want. All right, now that we have the full data and the complete case data and an indicator miss that can identify based on who has missing observation versus who do not have any missing observation, because we have created a binary variable, right? And based on that binary variable, 0 is associated with no missing and 1 is associated with at least 1 missing in one variables. So when we are doing a survey data analysis, obviously we can use the survey design function from the survey package, where we can identify the PSUs, weights, and strata, and in enhance the strata and cluster are nested. That's why we say nest equal to true. But when we're defining the data, if we define the complete case data, that will be a wrong approach to take. And the reason this is the wrong approach to take is because when we are using this survey design needs the full design information. That means like how many strata, how many clusters there were in the original design. Survey design needs those information to correctly calculate the variance. But when we are giving the complete case information only, we do not know whether we have information about all of these clusters or all of these strata. It could happen that for some of this cluster or in some of this strata, we may not even have any observation at all. And in this complete case data, we will not then have those information regarding the strata or cluster identification, right? So in that case, what will happen is that when we are doing the variance calculation and we are dealing with incomplete number of strata or incomplete number of clusters, we will end up with a wrong calculation of variance, which we do not want. So this is obviously a wrong approach to use the complete case data when we are designing our survey data analysis or the design object. The correct approach would be, at first, we will use the full analytic data to create our survey design. And then, based on the indicator variable that we have created, based on our eligibility criteria, and our eligibility criteria was we have to have complete information. And we are only trying to make inference about the subpopulation who have this complete information or no missing value. So miss equals 0. That means that we are only restricting to the subgroup of people who do not have any missing observations in any of these variables that we are dealing with. So this is w.design is a subset design, and this is a subset from the full analytic data based on this indicator variable miss. And we are going to use this subset design w.design. We're not using w.design 0. We are going to use w.design or the subset design in all of our modeling approaches. So that's what basically we are doing. We have already defined a formula, and basically our formula was this, that we are trying to predict the binary cholesterol level based on some of these variables that we have. And then we use the subset design to do our modeling. And then we will get all of these confidence intervals correct and the p-values correct. Otherwise, if we were using this analytic complete case data only, then we would get all of these. We may have gotten some of these confidence intervals wrong if we had missed any PSU or the strata that were in the original design, but in our subset design, they did not have any subpopulation within those particular strata or cluster. All right. So again, if we are trying to do any kind of variable selection and stuff like that, we are again going to use the subset design. We are never going to use the full design. The full design was this, and this was the sub design. So w.design was our subset design, and that is what we are going to use everywhere whenever we are going to do any analysis to get our confidence intervals correct. Thank you.